Okay, so now let's do the first construction. So how do you construct a random stochastic process, right? Gaussian stochastic process. So this is the first example in the book regarding this. So this essentially talks about something that we have already seen, discrete IID Gaussian process. Okay, so what is this? This is very easy. So you have to describe this by W of n such that n belongs to Z. You know what Z is? Hmm? What is Z? Yes,
Set of integers.
set of integers. Okay, it's two-sided. -1, -2, and so on, 0, 1, 2, 3, and so on. Okay, so you have this stochastic process where each samples W of 1, W of 2, and so on are chosen in IID fashion from Gaussian distribution, zero mean and variance sigma square. Okay, so now what is the mean process? W of n. Let me call this as mu of n, which is 0 for all n, right? So the mean function is 0, no problem at all. Now the next thing that I need to know is the covariance, right? So I'll take two time instance, n and k. Okay, don't get confused with the k that I chose earlier. So this is the covariance function of this stochastic process at time instance n and k. So what is this? This is nothing but expected value of w of n times w of k. What can you say about this? See, whenever n and k are not equal, they are independent random variables with zero means. So expected value of the product becomes product of expected values. The expected values are zero. Therefore, it will be zero. It won't, whenever n equal to k, this will be w square of k, which is variance sigma squared and Kronecker delta, right? So this, you know what Kronecker delta is? This is not the Dirac delta. Okay, so I'll write this here. Um, 1 if n equal to k, 0 otherwise, right? So this is a simple process like this. Hmm? So now how do you write the joint density? It's pretty easy, right? So if you take the joint density of n, k random variables, let's say w of n1 and so on, w of nk of w1 etc wk, this is the joint density. This is simply 1 by 2 pi sigma squared whole power k by 2, there are k random variables, exponential of this is IID, right? So it will be 1 by 2 summation I equal to 1 to k wi squared by sigma squared. Okay, so this is how you describe the joint density regardless of what k is and what n1 through nk are, right? Regardless of that, this is the distribution. So you know pretty much everything about this stochastic process. In
Hello,
fact, yes.
sir. Like, can you explain once? Like, here you have said there are two times n and k.
Huh. So this is
What
the
does that mean?
covariance, right? N and k. But whenever n is not equal to k, this covariance is zero. That means if you look at the covariance matrix of k random variables, the diagonals will be non-zero. Otherwise, everything else will be zero.
So my
Yeah.
question is, like, two
Hmm.
time instance of the n comma k you're telling. Then what is this
Correct.
n?
N is
How?
Wn, W of n, that is the random variable. So you take the stochastic process and look at what is the amplitude at time n. Discrete
Okay.
time. So think of it as a discrete time stochastic process. It's not a continuous time stochastic process. Other thing is k. For example, n is equal to 2 and k equal to 3. So you are looking at w of 2 into w of 3. Of course, expected value is 0 because they're not correlated, right? Did I clear your doubt?
Sir,
Yes.
maybe if you use k, m instead of k, it will be fine, sir. Because you have used k for number of vectors.
Okay, fine. If you are okay, so I'll just use a different color. M, M, M. Fine. You're okay with this? Ayush?
Yes, sir. Yes, sir. Yes.
Okay.
Sir,
Yes.
sir, will the diagonal elements be equal, sir?
Yes, in this case it's equal, right? It's sigma squared. Yes. So essentially the covariance will be sigma squared time identity. So the dimension of that matrix depends on K. If K is 10, it will be 10 cross 10. If it is 100, it's 100 cross 100. It doesn't matter which 100 samples you pick here because they are IID. Okay. Let's look at another example. Maybe it will be clear. This is an example which is again a discrete time example. So what I'm going to do is I'm going to write this as S of n, which is the sum. Excuse me, which is the sum I equal to 1 to n w of I. Okay, this is some process. Okay, so this w of n, right? So these are all IID random variables. Okay, is that fine? These are all IID random variables. I'm going to sum them to get a stochastic process which is S of n such that n belongs to n or n greater than or equal to 1. Okay, this results in a stochastic process. This is called the sum Gaussian stochastic process, right? Some Gaussian process, Gaussian sum process. Okay, now what can you say about expected value of S of n? This gives me the mean process, right? Mean of n. This is 0 because expected value of Wi is, Wi is or 0 mean Gaussian process. So it is 0. Now what is the next thing? We need to look at the covariance, right? So what will be the covariance? K, covariance of the sum at 2 points. Let's look at Nm. Okay, I'll change the notation. So this would be expected value of S of n times S of m, right? So S of n would be I equal to 1 to n Wi. S of m would be j equal to 1 to m Wj, right? So this is what we get. Okay. So now I can write this product as summation over all ij from 1 to n and 1 to m, w of I, w of j. But expected value of w of I, w of j will be non-zero provided I equal to j. So this will be I equal to j. Then only you will have this thing, right? So I equal to 1 to, well, I equal to j, but whether should we go till n or m, it depends on whichever is minimum, right? So nm, right? So expected value of wi squared is sigma squared, right? So this is nothing but, right, the minimum of n comma m sigma squared, right? The covariance of n comma m is whichever is the minimum, n or m, times the variance is the covariance, right? Is this fine? So now, this leads to an interesting notion called stationarity. Essentially, this covariance depends on what n and m are, right? For example, if n is 3 and m is 2, then it's 2 times sigma squared. If n is equal to 100 and m is equal to 200, it's 100 square sigma squared. So the variance changes depending on what n m you choose. Okay.